I am so thrilled that you are interested in visiting this video. I have poured my heart and soul into this to teach you to take all the steps, all the actions, and all the simple things that you are going to do. Let's get into today's video that is on differential equations of first order. So, the topic today is the formation of differential equations by eliminating the arbitrary constants. They are the four important questions here. So we have to eliminate the constants and we have to form the differential equation. The first question here is y is equal to a into e power minus 3x plus b into e power 2x. And the second question here is xy is equal to a into e power x plus b into e power minus x plus x square. And the third question here is y is equal to e power x times of a cos x plus b sin x. And the next one, the fourth question here is a sine inverse of x plus cos inverse of sine inverse of x plus sine inverse of y is equal to c. So here there are two constants here. If you see, there are the two constants here, a and b. So if there are two constants, you have to make a derivative for two times. So here there are two constants, you have to make a derivative for two times. Here also there are two constants, you have to make a derivative for two times. Here there is a single constant, therefore we have to make a derivative for one time. So here, let's get started to find the first solution here. We have to form the differential equations by eliminating the arbitrary constants. Y is equal to a into e power minus 3x plus b into e power 2x. So here is the solution. So first thing here is, first we have to make a derivative with respect to x. As there are two constants, first time I am making a derivative. So here for y, the value here is y dash. Clear? And for a it is a. So for e power 3x is again e power minus 3x for x1, so minus 3 will remain here. And the next one, the b is a constant and e power 2x is again e power 2x. For x is equal to 1, again I am using plus 2 here. Clear? And the next one, again we have to make a derivative, so differentiate with respect to x for second time, as there are two constants. For y dash, so here is y double dash. So here as usual this is a, so for e power minus 3x is minus 3x and again there is minus x. So in front there is minus 3 and this is minus 3, so here is a plus 9. And here, so b into e power 2x is e power 2x. So for x is equal to 1, 2. So 2 2s, the value here is 4. So this is the second equation. So here we have to eliminate a and b. So what are the equations here? So y is equal to a into e power minus bx plus b into e power 2x. And the next one here is y dash. Y dash is equal to minus 3a into e power minus 3x plus the value here is 2b into e power, the value here is 2x. So y double dash value is equal to a in 9 times of a into e power minus 3x plus b 4b times of e power 2x. Now how to eliminate this? So here is the determinant I am using. So in this determinant, see what I am going to do is, so we have to take the quotients of capital A and capital B. The quotient of capital A is e power minus 3x and quotient of B is e power 2x, and here the y value here is minus y. And next one, quotient of A is minus 3 into e power minus 3x and quotient of B is 2 into e power 2x and the value here is minus y dash. And here the value here is 9 into e power minus 3x and this value is 4 into e power 2x and this value is minus y double dash. So here this value, the determinant value here, it should be equal to 0. So here what we have to do, in the first column from C1 I am taking e power minus 3 common, e power minus 3 common, and from the second column I am taking e power 2x common, and from the third column I am taking minus 1 common. So here we have to take common from column C1, column C2 and column C3. And now the determinant will be, see what the determinant will be. So the determinant value is going to be, so this is 1, this is minus 3 and this is plus 9, and this is 1, 2 and 4, and here this is y dash, and this is y double dash value is equal to 0. And now here we have to find the determinant, that is 1 time of, so this is 1 into, this is 2 into y double dash minus 4 y dash, and this is minus times of, this is minus 3 y double dash, and this is minus 9 y dash, and this is plus y times of, this is minus 12 and this is minus 18, value is equal to 0. And see, this is 2y double dash minus 4y dash, and this is plus 3y double dash plus 9y dash, and this is 30 minus 30y is equal to 0. See here, if you see, this is 3 and this is 2. So here this will be 5 double dash. 5 double dash, and see, this is plus 9 and minus 4. The value here is plus 5y dash. This is plus 5 dash. This is minus 30y is equal to 0. If I take 5 common and cancel, this will be y double dash plus y dash minus 6y, value is equal to 0. So this is the differential equation after eliminating the constants a and b. So this is going to be the differential equations. This is how the differential equation is formed, and this is also so simple, as there are two constants, we have to differentiate for 2 times. So this is for the first time and this is for the second time, and therefore these three are the equations obtained. So here, in order to eliminate a and b, so we have to make a determinant by taking the quotients of capital A and capital B, and therefore from the first column I have eliminated, so I have taken common e power minus 3x, from the second column e power 2x, and from the third column this is minus 1, and therefore, and after calculating the determinant, we'll be getting the differential equations without constants. So the next question here is, by the elimination of an arbitrary constant small a and small b, obtain the differential equation. So this is the equation xy is equal to a into e power x plus b into e power minus x plus x square. So here, how many constants are there? Two constants are there. So xy is equal to a into e power x plus b into e power minus x plus x square. So here, if I make a derivative, differentiate with respect to x, differentiate with respect to x, if I make a derivative, then see, so this is of u v rule. So for x it is 1, y we have to leave, and next we have to leave x and we have to make a derivative for y, and see, a for e power x is e power x, and see, b for e power minus x is minus x, and this value is minus 1, and for x square the value here is 2x. Clear? And therefore again we have to make a derivative with respect to x, differentiate with respect to x here. So if I make another derivative here, so for y this value is y dash, for again you have to make uv rule, for x it is 1, you have to leave y dash, and again leave x here, and for y dash this is y double dash. So this is a into e power x, and this is b into e power minus x. For minus x it is minus 1, already there is minus, so it's becoming plus, and this value is 2. See, this is going to become, this is 2y dash plus x y double dash. So here, if you observe this one, a e power x plus b e power minus x, from this equation 1 can be written as xy minus x square. So here, from this equation 1, from equation 1 I am writing, so here a e power x plus b e power minus x can be written as xy minus x square. So the same thing I am going to write here as xy minus x square, this value is plus 2. So here if you write this one as xy double dash plus 2y dash, and next one this is xy plus x square minus 2 is equal to 0. Now we got a differential equation without the constants of small a and small b. Small a and small b. See here, so in this a e power x plus b e power minus x, we have to write xy minus x square, so that a and b are eliminated, and we got a second order differential equation. So as there are two constants, there will be double derivative, and if it is a single constant, we will be having a single derivative y dash. And next one, see here. Form the differential equations by eliminating the arbitrary constants capital A and capital B for the equation. So this is y is equal to, so this value is y is equal to e power x into a cos x plus b sin x. So here, first thing is we have to write this equation. Y is equal to e power x times of a cos x plus this value is b sin x. First, I am making a derivative with respect to x. Differentiate with respect to x. Differentiate with respect to x. So here this is u and this is v. So this value is u and this value is v. And see what happens here. So if I make a derivative, this is y dash. For e power x, the value here is e power x. And therefore I am writing a cos x. So for a cos x plus b sin x, I am leaving as it is. And for the second time, see here I am leaving e power x and making a derivative for this a. For cos x, this is minus a sin x. And for b, for sin x, this value is cos x. See, so this value can be written as y from equation 1. So here, if you see the value here, so this value is nothing but y here. So I'm writing this as y in order to make it short. So this is e power x, this is minus sin x plus this value is b cos x. And the next one, again we have to make a derivative, differentiate with respect to x for the second time as there are two constants. See here, this is also so simple. For y dash, this will be y double dash. This is y dash. So this is UV rule. So you have to make a UV rule. For e power x, the value here is e power x. And therefore, I am writing minus a sin x plus b cos x as it is. And the next thing here is, this time we have to leave e power x and we have to make a derivative for this minus a cos x. And for cos x, this is minus a sin x. This is b minus a sin x. And see, so in this place, what I'm going to write, e power x minus a sin x plus b cos x. So I can write as y dash minus y. So in this place, I'm substituting as y dash minus y. And see, this is going to become, so this is y double dash is equal to y dash. See, carefully observe, in this place I'm writing y dash minus y. So this is y dash minus y, and if I take minus common, this will be e power x into a cos x plus this value is b sin x. So if you observe this one, so a cos x, so e power x, a cos x plus b sin x value is nothing but y. So in place of this, I am writing the question y. So this is y double dash is equal to, this is y dash plus y dash minus y minus y. So this is going to become y double dash is equal to 2y dash minus 2y. And therefore, this is y double dash minus 2y dash plus 2y is equal to 0. So this is the required differential equation after eliminating the constants capital A and capital B. So this value is the differential equation after eliminating the constants A and B. And the next one, so form the differential equations by eliminating the arbitrary constants. A sin inverse x plus a sin inverse y is equal to c. So here, this is the question here. So in this question, if you observe how many constants are there, only one. C is the only constant. So now we have to make a derivative for one time. Differentiate with respect to x for one time. So for sin inverse x, what will be the differentiation? So 1 by root over 1 minus x square. And for sin inverse of y, this is 1 by root over 1 minus y square. And again for y, this is dy by dx. For constant, this value is equal to 0. So here automatically the constant became 0, and therefore there is an elimination of the constant done automatically with respect to x. So here I am sending this term to other side. So this is 1 by root over 1 minus y square into dy by dx is equal to minus 1 by root over 1 minus x square. If I send this to other side, then dy by dx value is equal to minus root over 1 minus y square by root over 1 minus x square. So if I send it inside, that is dy by dx, plus root over 1 minus y square by root over 1 minus x square is equal to 0. So this is the differential equation formed after eliminating the constants. This is how the differential equations are formed after eliminating the constants. If there are two constants, make a derivative for two times. If there are three, make a derivative for three times. If it is single, make a derivative for one time. And so that you will be getting a differential equation. And this topic is so simple, very easy. And I hope that one day maximum students will be benefited through this channel. And if you really like, please raise your thumb, pass it on to as many friends as you can, and that is the greatest help needed to this channel. And stay connected, and I'll be posting the whole chapter one after the other. Go through the playlist and your preparation will be damn easy. Thank you.